Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Oxymercuration of alkenes with HgOAc to an alcohol, EtOH, solvent proceeds via electrophilic addition following Markovnikov's rule. The mercury electrophile and the nucleophile, ethanol, add across the double bond in an anti-trans addition manner. Moving on to the next step. The starting material is 2-methyl but 2Na, CH3, CH3 is equal to CH3. The double bond is between C2, bearing two methyl groups, and C3. Moving on to the next step. HgOAc, 2 acts as an electrophile. It forms a mercurinium ion intermediate bridging the double bond. The nucleophile, EtOH, then attacks the more substituted carbon, Markovnikov selectivity, in an anti-fashion. Wait, actually in standard oxymercuration, the nucleophile attacks the more substituted carbon. Here C2 is more substituted, tertiary, than C3, secondary. And for the final step, the nucleophile, EtOH, attacks the more substituted carbon, C to the tertiary carbon bearing the methyl group, while HgOic ends up on the less substituted carbon, C3 the secondary carbon. This gives CH3C, CH3OH, CH, HgOic, CH3. The OH group is on C2, the more substituted Markovnikov carbon, and HgOic is on C3. This matches option B, CH3C, CH3OH, CH, HgOic, CH3. Why other options fail? Option A has HgOic on C2 and OH on C3. This is anti-Markovnikov placement of OH, incorrect. Option C has OH instead of OH on C2, wrong nucleophile. Solvent is EtOH, not water. Option D has HgOic on C2 and OH on C3, wrong nucleophile and wrong regiochemistry. Therefore, the correct answer is B. Therefore, the correct answer is option B.